Alright, today we're going to continue with Chapter 3, or actually start up with Chapter 3, which talks about inequalities in their graphs. Our objective of today, basically what we're going to be working with is the ability to write and identify solutions of inequalities and also graph them. Alright, so we're going to make a couple graphs of some inequalities, take a look at some real life examples of where we actually see inequalities in everyday life, and kind of just work with the new concept of this chapter, which is that concept of an inequality and exactly what an inequality is. Okay, so first of all, we need to talk about what we've actually been working with this whole time has just been different forms of quantities. Okay, now quantities are basically any number or any operation or combination of a number and an operation that form expressions, equations, and inequalities. If you remember way back, we talked about expressions. Okay, expressions basically is just a number and an operation, right? It has no statement. It makes no statement about that expression. Okay, 4 times x. Okay, notice it's not saying 4x is equal to anything. It's just saying 4 times a number, and we evaluate that expression. Okay, then we moved on to equations, which stated that something is going to be equal to another thing. All right, make statements about 2 different quantities. So an equation could be a 4x equals 16, where there's an actual solution to that equation. Alright, now today we'll work with inequalities. Alright, inequalities, which basically are kind of the same, only now we're transitioning and we're saying 4 times a number can be greater than, it could be less than, it could be equal, greater than or equal to some other quantities. Okay, so this is our transition, or kind of our flow of what we've been working with so far. Okay, so our definitions: vocab, inequality is any sentence that uses an inequality symbol to compare two expressions. All right, our inequality symbols, this should be a little bit of review. These 2 symbols can either be greater than or less than, depending on which angle or which, so to speak, alligator, or which way the inequality symbol is facing. Remember, if you think back to your early years of math, the alligator always eats the bigger number. So if we said x and we said this symbol and a 3, that would be x is greater than 3. Okay, since the alligator always eats the bigger number, the opening of the inequality symbol is going to say greater than or less than. Okay, our second set, again, these just add that or equal to, otherwise it's basically the same idea with our inequality symbols. All right, now a great example of an everyday inequality is something that you may see, or your parents may see on a day-to-day basis. All right, a speed limit. Okay, so let's say speed limit is 50 miles per hour. That means that our speed, all right, our speed can be no greater than 50 miles per hour. All right, that is our limit. That is how fast we can go. That is 50 miles per hour. Okay, so our speed has to be strictly less than 50 miles per hour. Okay, depending on the cop, maybe we could say less than or equal to 50. They might let you get away with 50. Okay, even though your parents may speed a little bit frequently, I know I certainly do. But basically, this is a good example and a good way to think of what an inequality actually represents. All right. Now, let's take a look at some actual examples of writing those inequalities. And again, this is very similar to how we write an equation. All right, on letter A, it says all real numbers x less than or equal to a -7. All right, so we're going to take a look at just the first half of that, all real numbers, okay, and x is our variable, so we're just going to say all real numbers x, and since it is less than or equal to a -7, x less than or equal to a -7, okay, not too tough. Letter B, 6 less than a number k is greater than 13. Now this one can be a little tricky because we see it says 6 less than a number k. Okay, and we need to examine the difference between less than a number and 6 is less. Okay, so this is a little bit tricky. 6 less than a number k, we're going to start with that k, and since we're taking 6 less than that number, we would say k minus 6. Now we can evaluate the second half of that inequality, is greater than 13. Okay, so is greater than, the alligator is going to eat the greater side, or is greater than 13. Okay? So again, this is just writing those inequalities. All right? We'll take you through one example of a real life scenario. Okay? One that I actually experienced this weekend. All right, combined weight of an elevator can be no greater than 1,600 kilograms. Write an inequality to represent this situation. And then, if there are 10 people in that elevator, how much can their average weight be? Okay, I think all of us can at least think of one instance when you've been in an elevator that's been a little bit too packed, all right? And I had that multiple times this weekend. So combined weight in an elevator, let's just call the weight W, all right? Says that it can be no greater, all right? No greater than 1,600 pounds. Can be no greater than 1,600 pounds. So we know we're going to deal with 1,600 somehow. And since it is no greater than that, all right, no greater means it has to be strictly less than 1,600 pounds. Okay? Then it says if there are 10 people in the elevator, how much can their average weight be? So we're going to take the average of 1,600 kilograms and divide that by 10 people. All right, cancel off a 0, 0. Our average weight has to be the average weight. We'll say average weight has to be less than 160 kilograms. Okay? Average weight has to be less than 160 kilograms. We're going to separate these two. Okay, so again, just a real life scenario that you may come across. Now, identifying solutions to inequalities. Again, very similar to how we treat it with an equation. A solution of an inequality is a number that makes the inequality true. Okay? Just like a solution of an equation is a number that makes that equation true. So solutions, there are going to be multiple ones in this case. Solutions of x is less than 5. Or all numbers, we can think of it like this. All reals less than 5. Okay? So some examples, obviously 4, 3, 2, all numbers that are less than 5. Okay? So basically all we need to do to check these solutions is very similar to how we check an equation. We substitute and then we check using the order of operations. Okay, so if you wanted to check 4, all you do is plug 4 in for x. Obviously we're going to get tougher than x is less than 5. 4 is less than 5, so that would be a solution to that inequality. Okay? Let's take a look at this example. Is the number a solution of 2x plus 1 is greater than a negative 3? Okay? The number that we're checking is negative 3. So all we do, again, number 1 is substitute. And then we solve keeping in mind our order of operations. All right? In this case, we plug negative 3 in for x. So we're going to take 2 times a negative 3 plus 1. And check if that's greater than a negative 3. And our substitution went right here, negative 3. So 2 times a negative 3, that's negative 6 plus 1 is greater than negative 3. Negative 6 plus 1, that's a negative 5. Now, is that greater than a negative 3? Is negative 5 greater than negative 3? Well, if you're $5 in the hole, you're kind of less. That is not greater than a negative 3, so this one would not be a solution. Okay, so this one would be an example of one that would be not a solution. Okay, a couple examples of ones that would, if you just checked 1, all right, 2 times 1 is 2 plus 1 is 3. 3 is greater than negative 3, so there are plenty of solutions that would be would work for this scenario. Okay, so again, all you really need to do though, this is kind of the important part, substitute and solve. Now, graphs of inequalities are relatively simple. Inequalities are graphed using just a simple number line, just like this one. All right, so if we've got x is greater than a negative 3, x is greater than a negative 3. Anytime you're dealing with greater than or less than, this is going to equal out to being a open circle on the number. Okay, so if we're dealing with less than or greater than, again, it's an open circle. That open part is pretty important. So in this case, x is greater than negative 3. We're going to find negative 3, and it's going to be an open circle. Okay? And from there, we need to shade in all values of x that are greater than negative 3. So negative 2 is greater than, and we're going to go actually this way. Alright? Now, a nice little hint, whenever you see the x on the left side of the inequality, okay, the x on the left side of the inequality, it will always point in the direction that you're going, okay? So if we have x is greater than a negative 3, again, that's all values that are greater than are going this way. Okay, one helpful hint. Now, if you're dealing with greater than or equal to, or less than or equal to, again, this one will be a closed circle. Alright, closed circle, meaning that you'll be right on that value and then go left to right. Okay, and we'll take a look at some more examples. Alright, so n is less than or equal to 3. Okay, notice we've got our variable on the left side, so the direction of our shading is going to go whatever direction this symbol is pointing. Okay, so we find 3, since it's greater than or equal to, or less than or equal to, we have a closed dot, and all values that are less than 3 are going to go this way. Okay. Now this one is tricky just because they're flipped. If you want to, you can flip this back and rewrite it as x. If we were to just flip this, again, we'd flip the numbers and we'd need to flip the symbol. So we'd say x is less than a negative 3, okay? And now we've got it in the form with our x on the left side, so we just go in the direction of our symbol, okay? Find negative 3, which is right here. And since it's less than, or it's pointing that way, it's all values less than a negative 3. Okay? This last example, let's just write what the inequality would be. Okay? Notice we've got an open circle. Okay? We've got an open circle, so we know it's got to be either less than or greater than, meaning it's not including that value of 3. Okay? So let's just pick a variable. Let's just call it x. Okay? And this is all values that are strictly less than 3. Okay? So all values that are strictly less than 3. All right? Again, kind of an introductory section to Chapter 3, dealing with inequalities, and we'll work on it a little bit more tomorrow in class. All right, have a good day.